Hi everyone, today's notes number 3, is going to be all about the sine function. So last video we talked about the tangent. The tangent basically said that if we wanted to find the tangent of an angle, we would look for the side that was opposite, and we would make that the top of a fraction, and the side that was adjacent to it we would put on the bottom. What happens with the sine is now we're still going to use that side that's opposite. However, now the denominator of the fraction will be the hypotenuse. Make sure that you have a calculator to start, whether it be your cell phone calculator or a scientific, or if you have one of these, okay? And let's get started. So, as I mentioned, we are doing notes number 3. We're still working with right triangle trigonometry, and this time though we're working with the sine ratio. The sine of an angle A in a right triangle is the ratio. Again, like we said before, this is just fancy word for fraction. So it is the fraction of the side opposite of A to the hypotenuse, meaning opposite on the top and hypotenuse on the bottom. And that SIN is just the abbreviation for sine. We do not say sin A, we say sine of A. In the directions, I apologize for my little typo here. Your worksheet that I attached on Google Classroom will say sine. I just had accidentally printed out the slide and I didn't want to waste the paper. Super expensive, the stuff I have to use. So we're finding the sine of the indicated angle. We're going to express our answer as a fraction, as a decimal, and when we round the decimal, just to make sure we're as accurate as possible, we're going to round to 4 decimal places. This is actually going to look super similar to what you just had for the tangent notes, except I've now just changed it to the sine. If you remember from when we did the tangent, we said that the most important part was being able to label the sides as either hypotenuse, opposite, or adjacent. So just like we had done with the tangent, the first thing I want you to do is make sure you know where the hypotenuse is. So identify where that right angle is. Where he points to is always his hypotenuse. So the 13 is definitely going to be the hypotenuse. Then from there, let's look at the problem and see what angle they want us to find the sine of. In this case, it's angle T. So I'm going to go up to my picture, look to see where angle T is. Now we need to figure out, well, who is the opposite and the adjacent side from that angle? The strategy that we had talked about before was to actually take that angle and just go ahead and draw a line to both of the other sides that are not the hypotenuse. So we're drawing just to the 12 side and the 5 side. Whichever side took the longer arrow to get to, that is going to be our opposite side. So I'm going to put O for opposite. The one with the shorter arrow is going to be our adjacent side. So labeling what we've got here, we've got the 5 as the opposite, the 12 as the adjacent, and the 13 as the hypotenuse. Again, now that we're looking for the sine of T, we no longer are concerned with the adjacent. In fact, all we're concerned with is the O over the H. We're looking for the opposite over the hypotenuse. So we're going to take the number that's the opposite, and that is 5. Take the number that's the hypotenuse, and that is 13. So 5/13 is going to be the fraction. If we wanted the decimal, when we do 5 divided by 13 in our calculator, we should get 0.3846. And that is the sine of angle T. Moving on, number 2. Again, I gave you 4 problems like this because, again, I really want you to get good at the labeling part. So first and foremost, find that 90-degree angle, identify the side that it is pointing to, the side that is across from it, and that will be your hypotenuse. So we've got 25 for our hypotenuse. The angle that they're asking for down here is angle G. So go ahead and circle angle G. And then go ahead and draw an arrow to each of the 2 other sides. Whichever side took the longer arrow to get to, that'll be your opposite. The one who's closest is your adjacent. Remember that the word adjacent just means like next to, okay? So that's why it's the closest guy. And again, we're using opposite over hypotenuse, so the opposite number is 24, hypotenuse is 25. So for our sine of G, we would say it is 24/25. When we type 24 divided by 25 in our calculator, ooh, very pretty, we get a terminating decimal of 0.96. If you want to add the 2 zeros to the end because we said 4 decimal places, that would be completely up to you. Obviously, those zeros are not significant figures. In this case, it's not really changing the value. Moving down to number 3, again, the triangle kind of looks a little awkward, doesn't really look like a right triangle to begin with. And just so we're clear, guys, all this stuff we were talking about with the tangent and now with the sine is only done with right triangles. So number 3 doesn't really look like a typical right triangle, but notice that we do have a marking for it. So it turns out it's just kind of like sitting on its side, if you will. Across from that 90 is your hypotenuse, so 5 is your hypotenuse. And we want the sine of angle L. So L is the one we want, so go ahead and identify where L is, and then draw your lines to the 2 other sides. The longest one will be the opposite. Your shortest one is your adjacent. And by longest and short, again, I'm talking about the length of these arrows from the angle to each of the other sides. And following through again, remember that sine is O over H. So that would be your 3 over 5. Dividing 3 by 5, we'll get another pretty decimal, we'll get 0.6. Again, if you want to add those zeros at the end so that it's got 4 decimal places, that would be completely up to you. Now, hopefully what you're noticing so far is that the hypotenuse always ends up being the largest number in the triangle. Remember, the hypotenuse is always the longest side of any triangle in a right triangle because the 90 is always the bigger angle. So if I'm taking a look at number 4, you know, maybe I don't necessarily need to say, oh, where's my 90? Let me look across. Maybe I just look at my numbers. 21, 20, 29. 29 is the largest, so I know it's got to be the hypotenuse. Again, you can double check by looking at that 90 degree, but again, when you're given the 3 numbers in a right triangle, the biggest number will always be the hypotenuse. As far as the others with opposite adjacent, that's where you're going to have to draw your arrows and look. All right, we want the sine of angle P, so we identify P right here, and then we've got our 2 sides, 21 and 20. 21 is the longest one it takes to get there, so that's the opposite. 20 is your adjacent. So now again, doing the opposite over the hypotenuse, that's going to be 21 over 29. I definitely don't know that one off the top of my head. 21 divided by 29. All right, it's a little bit ugly. Let's go ahead and figure this out. It's going to be 0.7241. Notice that, unlike the tangent, every single one of these numbers is less than 1. So if you remember for the tangent, sometimes we got like 1.73, yada, 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 or 2 points, something, something, something. Do you know why the sine values will always be less than 1? Well, we just mentioned that the hypotenuse is always the largest side or the longest side of a right triangle. So whenever you create the sine fraction, the bottom will always be bigger than the top. So anytime you're working with the sine and you find the decimal, if it ends up being bigger than 1, you know you did something wrong. Remember that as we move on to our next problems on the next page, where now we're going to have to write and solve a trig equation that uses sine. Again, apologize for the typo, but your paper, if you got it from Google Classroom, should be correct. You're going to write and solve a trig equation that uses sine to find the missing length. We're going to round our trig values to 4 decimal places first before we continue to solve. So again, first things first is to make sure we can label all of our sides. Now, unfortunately, we're not given all the 3 sides of the triangle. In fact, we're missing one that we're looking for. So I don't know what this number is if I don't locate my 90-degree angle first. So here's my 90. I look to see who he's pointing at. Yep, looks like it's the 8. So the 8 is our hypotenuse. And just to double check, our 33 right here, which is the angle in the problem. If I draw an arrow to the other 2 sides, the longer arrow points to the x, so that's going to make that my opposite. It's going to make this bottom one the adjacent, but if you remember when we did the tangent equations, I really just need those 2 sides, opposite and hypotenuse. So there will be that one side that has nothing on it, but that's okay because I don't want to use that anyway. Okay? Remember we had said the sine was opposite over hypotenuse, so those are the only 2 sides I'll need. To get started with our equation, now that we know that we're doing sine, we're going to start with that sin and then the angle in the problem. And that again is equal to the opposite over the hypotenuse. In this problem, the opposite is x, the hypotenuse is 8. So this is my equation that I have created. Now some tips that we had mentioned in our last video. I always like to take my trig function and put it over 1, so it just looks like a proportion. And I know that to solve a proportion, I just have to cross multiply. Now, another thing that sometimes people get goofy about is the whole sine of 33, okay? It's kind of awkward to solve an equation when you have a whole word in it. So we're going to take away the sine of 33 by replacing it with its actual value from the calculator. Hopefully by now you've kind of worked out what calculator you're using and how you need to go about typing this in. I know on a traditional calculator, Texas Instrument mainly, Casio's, most of the time you'll hit the sine key, which will say SIN on it. It's 2 to the left of the tangent key. You'll hit that key first and then a 33 and you'll get your decimal. It should be 0.5446. Some other calculators or some other cell phone calculators will have you type the 33 in first and then hit the sine or the sin key. That's how I know my iPhone works. And then in that case, as soon as I hit the sine key, the decimal will just pop up. I don't even need to hit equals or enter. So everybody's calculators or technology will be a little bit different. The most important thing is that you contact me if you're not getting this decimal, okay? So we've replaced sine of 33 with 0.5446. Don't forget to continue to write that over 1. And of course that's equal to x over 8. So now we're here ready to solve this proportion. Remember that to solve proportions, all we do is cross multiply. So we're going to do the 1 times the x, and that will give us 1x, or just x. And we will do the 0.5446 times 8. So 0.5446 times 8. And that will give us 4.3568. That actually does terminate. So you can either give me that answer, or chances are, if this is on the quiz and I'm giving you multiple choice, I'll probably just round it to 2 decimal places. So my rule of thumb is, although I round the sine or the trig function of 4 places to maintain accuracy before I start solving, usually by the end I just do 2 decimal places. Moving on to number 6. Again, let's go ahead and label all of our sides first. So locate where your 90 degree is. Wherever that corner is pointing, there's your hypotenuse. So this time our x is our hypotenuse. And the angle in the picture is the 50. So we're going to go ahead and point to the other sides. That's going to make our, I pointed to the wrong side, pointed to the wrong side, pause, pause, pause. when we go ahead, it's like I did this on purpose though. All right, remember what we said, guys? The reason for labeling that hypotenuse first is because that way it takes it out of the running as far as who's going to be the opposite or the adjacent. So what I should have pointed to was this side right here, which again has nothing on it. It is the adjacent, by the way, but it has nothing on it, so we don't really care so much about it, okay? Again, the whole point is that we really just needed that O and H. However, I just keep labeling all the sides just to make sure we get good at it. Because believe it or not, the very next notes will be something called the cosine or the cos, and then you will need that adjacent. So you want to make sure that you're good at labeling all the sides, even if it's not a side that you need for the current trig function. All right, so moving on. So now I've got everything labeled. So I take that SIN and then the angle, which is 50. And that is going to equal the opposite, which is 27, over our hypotenuse, which is the x. And just like before, we're going to go ahead and throw that sine of 50 over 1. And we're going to go ahead and take our calculator and find the sine of 50. And I am getting 0.7660. Behind the 0 was a 4, but remember our little rhyme, 4 below, let it go. 5 or above, give it a shove. This is 4 below, so we're going to let that go. And then just finishing up and rewriting what we've got so we can see it more clearly. This is the proportion that we are going to solve with cross multiplying. When we cross this time, our x ends up getting multiplied to that decimal, so it will be 0.7660x. The 1 gets multiplied to the 27, so that's what this equation is going to equal. To get x alone, we're going to want to go ahead and divide by the coefficient, that 0.7660 onto both sides. It will most likely not be pretty. Let's go ahead and see. 27 divided by 0.7660. Ugh. All right, I'm not even going to bother to write out a bunch of decimal places. Remember what I said about this one? Let's just go to 2. So it looks like 35.25. This number had originally been a 4, but behind it was an 8. And that's where the 5 or above, give it a shove, comes into play. Now just taking a look at these two problems real quick, okay, something else that I want you to look at as far as kind of double checking, making sure your answer is reasonable. First thing is what we talked about on the first page. Remember we had said that the sine value should always be less than 1. So as soon as you do type in your sine of the angle, if this decimal is something bigger than 1, you made a mistake. You might have hit the wrong sign, okay? And by sign, I mean S-I-G-N, meaning like the button, not S-I-N-E. Okay. Also, another thing, guys, remember we mentioned that the hypotenuse has to be the longest side of the triangle. So, for example, this one for number 5 had a hypotenuse of 8. Well, if I would have come up with an answer that was bigger than 8, then hopefully I would have stopped and said, wait a minute, that's not going to make sense. A side or a leg in a right triangle cannot be bigger than the hypotenuse. So the fact that we got something less than 8 gives us a pretty good feeling that this is right. And then same thing over here. Okay, now we were looking for the hypotenuse over here. Okay, we used 27 as the opposite side. We ended up with an answer that was bigger than 27, and that should make sense because the hypotenuse should be bigger than either of the sides or the legs in a right triangle. If this would have been smaller than 27, that's when we would have stopped and said, whoa, 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 I did something wrong. Maybe I set something up incorrectly, pressed a button wrong, something like that. So think about these things as you go through these problems to just make sure that your answer is reasonable. Now let's move on to the word problems, which is basically going to have us doing exactly what we did up here, but again, just putting in that real world spin. So we're going to write and solve a trig equation that uses sine to answer the question, and we're going to do the same thing we just did above. So here we've got a ladder, and it's leaning up against the wall here. The base is always the bottom, so the base of the ladder forms a 65-degree angle with the ground. We also know that the ladder reaches 12 feet up, so from here to here is 12 feet. And we want to know what is the length of the ladder. So if you notice, we've got our right triangle right in here. And if we take a look at the sides that we have across from the 90-degree angle here, here's our hypotenuse, so it looks like our hypotenuse is the H. If we then take a look at the angle here, the 65, and draw arrows to the two other remaining sides, the longer arrow is to the 12, so that must be our opposite. And the ground in this case is our adjacent. Now again, it told us to use the sine function, but hopefully that kind of makes sense that there was really no other one that we could use, because we know we need the x, which is the hypotenuse, and the only other number they give us is the 12, which is the opposite. So the only possible thing to use would have been the sine. We wouldn't have been able to use the tangent because we don't have anything there for a. So setting up our equations just the same way we did up top, we've got the sine of 65 degrees equals the opposite, which is 12, over our hypotenuse, which is x. All right, at this point, doing the exact same thing we did up top. Throw this over 1 so you don't get confused. Go ahead and type the sine of 65 in your calculator. That way you don't have to worry about manipulating with a word or letters. We can just do it with numbers. So the sine of 65 ends up being 0.9063. And of course that's going to be over 1, and it equals 12 over x. Much like number 6, if you notice when we cross multiply, the x is now getting multiplied to the decimal. So that means we're going to have, just trying to secure this a little bit for you. All right, so when we cross multiply, that's going to give us 0.9063x. Crossing the other way is going to give us 12. We're going to have to divide by that ugly decimal, so divide by 0.9063 on both sides. All right, so 12 divided by 0.9063. Whew, ugly decimal, and actually, look right here, it says to round to 1 decimal place. So if it does specify rounding, please follow those directions. Okay, the number I'm getting is 13.24064, blah. I just want 1 decimal place, so that means I keep the 13, then the decimal place. The number after it is a 2, and I know it's going to stay as a 2 because if you look at your calculator, the number after the 2 is a 4. So 4 below, let it go. So that means our ladder here is approximately 13.2 feet. All right, we're just going to do 2 more examples and then you'll be ready to try the homework. Just as a quick note, guys, okay? Remember, as I said on Google Classroom, I'm not requiring that you turn in the homework. The homework is strictly for you to practice. The way we're going to calculate our grade so far is with the quizzes that will be at the end of each week. If you would like to start handing in homework, you think that's something that we should be doing, then please let me know and we can work out something different for the next unit, okay? All right, so number 8. Now number 8 is a little bit different than we've been doing before. These problems are popular when you talk about sometimes with physics, or if you go into some upper level maths, we talk about bearings. Or actually, if anybody's interested in flying, okay, you'll work with bearings. So this is one way to do bearings. So we have a plane leaves an airport. Here's our little plane. Here's the airport. Okay, a plane leaves an airport and travels on a bearing of north 70 degrees west. So just to clarify what that means, now I'll always give you the picture, so you don't really need to know. But if you're curious, north 70 degrees west means that the plane left and kind of was going north, but swayed 70 degrees to the left. So from here to here is that 70 degrees. So you're going up, but yet over to the western direction, 70 degrees. So this is the path that the plane took, and as it says, it went for 100 miles. So even though you don't need to know the bearing, I'll always give you a picture. That's just something good to kind of keep in your pocket for later. All right, so we've got a bearing of north 70 degrees west and a 100 degree there. At this point, how far west is the plane from the airport? So all I'm looking for here is this X, which is representing that west direction from where the airport is, which is right here. So go ahead and label your picture. We've got the 90 degree angle here. Across from the 90 is going to be that 100. As far as where our 70 is, well, across from the 70, right here's the X. This guy would be your adjacent. However, again, there's nothing on there, so we're not going to be concerned with using that. We're writing the sine equation. So again, we start with our SIN, our angle, which is 70 degrees, our opposite, which is X, and our hypotenuse, which is 100. From there, again, we're going to go ahead and throw that over 1, so it just looks like a regular proportion, something easy to solve. But you know what would make it even easier? If we just got rid of that sin, that sine. So we're going to go ahead and take our calculator, again, sine, and then 70 degrees. All right, this time we're getting something big, 0.939. Now the next number says 6, but the number behind it is 9. So we're going to bump that 6 up to 7. So we get 0.9397 over 1 equals X over 100. And now when we go ahead and cross multiply, we notice that the 1 on the bottom is what's going to get multiplied to X, so we'll get 1X or just X. When we multiply this by 100, well, again, you can grab a calculator, but remember that when you multiply something by 100, that's the same exact thing as just taking that decimal point and moving it to the right 2 spaces. So this is going to end up giving us 93.97. Now I'm looking at the directions. It says to round to 1 decimal place. Well, the thing is if we round this to 1 decimal place, that means we want to see a number here. But if we look behind it, it's already a 7. 5 or above, give it a shove. Well, if you give a 9 a shove, that bumps them up to 10. So what this actually rounds to is 94.0. So that would be 94.0 miles. And we're just going to do one more problem, and then you are done with sine. Number 9. All right, this talks about an angle of depression. It says the angle of depression is 11 degrees from the bottom of a boat to a deep sea diver at a depth of 120 feet. So basically this is what's happening here, guys. If you picture kind of the water, the level of the water as being the top of this triangle. When we say an angle of depression, we're talking about from this boat and their kind of water level down 11 degrees. The opposite of this would be an angle of elevation, which means from your eyesight, you'd be looking up. But in this case, because it's downward, we would say that is depression. Again, just like with the bearings, I will always have the pictures labeled, but I do want to make sure that you feel comfortable with the terminology. So we've got the angle of depression there at 11 degrees, and they are showing us an actual rectangle down here. But remember, we've done problems with rectangles before where we just really focused on just half of it. So you just focus on the half of the picture that has all the information you need. It's got the 11 degrees in there, and I'm just going to write over top so this is a little bit more clear. It's got the 120 here, and it's got your X right here. The 90-degree angle right here. So we're just going to focus on that orange highlighted triangle there. And from there, take a look at our different sides and labeling what we have. So across from the 90, boom, 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 will be the diagonal, which we know has an X on it. Across from this 11-degree angle, all the way over there, that's going to be our opposite. This one up here is going to be your adjacent. But notice that we do not need that because our sine is always just O over H. So to write out our equation, we've got sine of 11 degrees equals the 120, because that's our opposite, over the X, which is our hypotenuse. Sine of 11, probably something tiny. Yep, it's going to be 0.1908. You may have noticed as we've gone through these examples that the tinier the angle, the smaller the sine is. All right, we're throwing that 1908 over 1, and then let's go ahead and rewrite this proportion. Oh, sorry, this guy was over 1. We rewrote it with the decimal. Now we're ready to cross multiply. So the X is getting multiplied to 0.908, so we'll have 1908x, and then across from here, the 1 and the 120, 120. Of course, we're going to have to divide by the 0.1908 onto both sides. So 120 divided by 0.1908. Let's see, we get 628.9308, yada, yada, yada. Let me just reread what we got. It says, find the distance X the diver must swim. So here's our diver. How far should he swim to get to the boat? And we want it to the nearest foot. So that's basically them saying, I don't want decimals, just give me the number. So if you notice, we only want the whole number because we've got a 9 behind there. That must mean that this 8 is going to get bumped up to a 9. So it'll be 629 feet. Again, just thinking about what we talked about as far as checking the reasonableness of your answer. 629 in this case is the hypotenuse. So it makes sense that it is something bigger than the opposite side, which was the 120. Let's see, over here, we were looking for the opposite side. The hypotenuse was 100. So it made sense that that opposite side was less than 100 because the hypotenuse always has to be bigger. So little things like this, guys, I want you to think about as you go through the practice. If you have any questions, let me know. Our next video will give us the third and final of the trig equations, the cos key, cosine, and then we'll just have a few more sections and we'll be done with the unit, okay? Again, if you have any questions, make sure you email me or shoot me a message on Remind. All right, I'll see you later. Bye.